So, introduction to the discriminant. The discriminant tells you the number and types of solutions to a quadratic equation, and to find the discriminant you use or find b squared minus 4ac. Remember, that's all of the stuff underneath the square root in a quadratic formula. So if I have the equation x squared minus 5x minus 24, if I have that quadratic equation, and I use all of these values in that, it's going to tell me how many solutions I have. So if you look, the number in front of x squared is always a, so a equals 1. The b equals -5, and the c equals -24. Okay, so you're going to use the values that we just wrote out in this equation. So b squared, so it would be -5 squared minus 4 times 1 times c, which is -24. Okay, then once you do that, or once you write that out, you're going to actually use your calculator to find it. Now, there's a couple of things. If you wanted to do it by hand, remember you have to follow order of operations, so you'd have to square first, then multiply. Don't subtract that 4 until after you've multiplied. So I'm going to just go ahead and type it in because your calculator will do it for you. So -5, make sure you put it in parentheses or it's going to mess up the problem, squared, minus 4 times 1 times -24. So the answer is 121. You can also, I'm going to just quickly do it by hand just for anybody that doesn't like using the calculator. And that would be 5 squared, or -5 squared, which is -5 times -5, would be 25. Minus 4 times 1 times -24. -4 times 1 would be -4 times -24. 4 times 24 is 96. A negative times a negative is a positive, so it'd be plus 96. So 25 plus 96, 6 plus 5 is 1, is 11, carry the 1, 9 plus 2 is 11, plus 1 is 12, so 121 would be your discriminant. This is the answer to your discriminant. So that would mean you would take, if you were using the quadratic formula, you would take the square root of it and then add and subtract 11. Okay, we're going to do another example, and then we're going to talk about the types, or what it means by the types of solutions. So if we have x squared plus 4x plus 4 equals 0. Let's find all of our values. A is 1, B is 4, and C is 4. So opposite of B, or not opposite of B, I'm sorry, just B squared. So 4 squared minus 4 times A times C. Type it in your calculator. 4 squared minus 4 times 1 times 4 is 0. Okay, so 4 squared is 16. -4 times +4 would be -16. 16 minus 16 is 0. So that is why that one's answer is 0. Okay, we have one more type. Notice we've had a positive solution, we've had a 0, now we're going to get a negative solution, and I'm going to show, or a negative discriminant. So A is 1, B is 4, C is 8. So B squared minus 4 times A times C. 4 squared is 16. Minus 4 times 8 is 32. 16 minus 32 is negative 16. Go ahead and type it in just to show you. Minus 4 times 1 times 4. Oops, I typed in the other one. Sorry, I'm losing my mind this morning. Minus 4 times 1 times 8 is negative 16. So if we were to use, so we talked about if you use this one, if you use that in the quadratic formula, it would be whatever plus and minus 11. So you would have to add and subtract 11 to that. This one, whatever it is, it would be plus and minus 0. Well, if you add 0, you're going to get some number. If you subtract 0, you're going to get that same number. So that's why we're going to talk about the types of solutions in just a minute, what this number tells you about your different solutions. And then this one. If you have a negative 16, that was what was underneath the square root. If you try to take the square root of a negative 16, watch what happens. So square root of negative 16. Notice it tells you non-real answer. So anytime you're doing the quadratic formula and it tells you non-real answer, that means the solution is not a real solution. It's not that there is no solution, it's that there's no real solution. So something that we're going to be talking about in the next couple of days is imaginary numbers. So when you take the square root of a negative number, it's an imaginary number. So let's go ahead and write this. Discriminants. Types of discriminants, sorry. I just ran out of room. It's okay if this is on the same page as that you were working on. So if you have a positive number for your discriminant, it tells you that there are 2 solutions. If you have a 0, that means it is 1 solution. A double root. And then a negative number means no real solutions. No real solutions. So positive number gives you 2 solutions. A 0 only gives you 1. And a negative number gives you no real solutions. And the reason why, you can write this little note if you want to. The square root, that color never works, I don't know why, I pick it up every time. Square root of a positive number, like 49, would mean you add and subtract 7. If you have a 0, I picked up that same dang color. A 0, or the square root of 0 equals 0, so you would add and subtract 0, which wouldn't change it. It would be whatever the other number is. So this is just the y that is. So you can look back at it later. And then, of course, that green doesn't work. And then if you take the square root of a negative number, you get no non-real answer. Up until this point, you have been told that you cannot take the square root of a negative number. You really can, it just doesn't give you a real solution. Tomorrow we're going to talk about imaginary solutions. So that is how you find the discriminant. I will type in real quick. I know I'm at 10 minutes, but I'm going to go ahead and type in the equations. So let's say y equals x squared minus 5x minus 24, x squared plus 4x plus 4, and then x squared plus 4x plus 8. So the first one, remember, was a positive number, so it has two solutions. The second one had a 0, so it was a double root. And then this last one, notice it never crosses the x-axis, so it doesn't have any zeros or solutions. That's why we call them imaginary. It would still, like if we shifted that down, it would still cross. It's still a quadratic, so there's always a possibility of two solutions. It's just that this one, since it's up or shifted up above the x-axis, it doesn't have any real solutions. It would still have a solution, it's just a non-real solution. So I did want to show you that graph.